So what are we doing today?
Solving system of equations.
So before I can teach you how to solve a system of equations, I need you to know what a system of equations is. Do you know? Can you use your context clues? A system of equations?
Equations.
Multiple equations, right? So I'm going to write system of equations. So multiple equations. The systems of equations that we're talking about today are going to have two variables. Okay? What variables do you think those are going to be?
X.
And?
Y.
X and Y, right? Hopefully you know since we're graphing them, it kind of needs to be X and Y, right? Okay? Because we have two variables, how many equations do you think we need? Two, right? If we have two variables, we need at least two equations to be able to solve the system. All right? Now, here's the deal. If I have since we have two variables, I'm just letting you know today we're talking about linear equations. Okay? So, if these are my two lines, what do you think I'm looking for? Like, where is the solution? Where they cross. Okay? So, how many times are they going to cross? Once? Twice?
What?
Will two lines ever cross in two places?
No.
Not lines, right? Two lines can only ever cross in one place. Or never. Or everywhere, right? Okay? Those are our only three options when we have two variables. When we're talking about linear equations, okay, which is what we're talking about today. Does that make sense to everyone? All right. So tell me again, what are we looking for? Where they cross, where they intersect. So we're looking for the point of intersection. We're looking for that one point where they cross. Is everybody okay with that? All right. So here's what a system of equations might look like. I might say x equals -3 and y equals 1/3 x minus 3. Okay? That's a system of equations, isn't it? We've got two equations. Now the top one only has an x. Is that okay? Yeah, doesn't that actually make it a little easier for us? Okay? I'm going to graph this first one with pink, if you care. How do I graph the line x equals -3? So exactly, right? If there's only one variable, it's telling me which axis it's crossing and where it's crossing that axis, right? So this is crossing the x-axis and -3. So what kind of line is it? Which is also called a vertical line, right?
Yeah.
Isn't that the line x equals -3?
Yes, ma'am.
Okay. Do you remember how to graph this line? Two variables. Now, I know you know how to graph this in a calculator, but I don't want you to be just a button pusher, right? I want you to have some knowledge. So do you remember you have to start with the y-intercept? Very good. So it crosses the y-axis where? -3. So down 1, 2, 3, and I put a dot. And then what do I do with the slope?
Rise over run.
Rise over run. So I rise 1 and I run 3. 1, 2, 3. How many points does it take to make a line? 2, right? Can you see that line very well? Kind of, right? But what if I did this? Rise 1, run 3. Rise 1, run 3. Rise 1, run 3. Rise 1, run 3. Is that better to see the line? What if I went down 1 and run backwards 3? Is that allowed? Now, is it easy to see the line? Very, right? While only 2 points are required, if we put, what did that take, 10 seconds? 10 more seconds into putting all the dots there, isn't it much easier to see the line? Not only is it easier to see the line, but can't you see the point of intersection now? Okay, so I'm going to go ahead and draw my line. Now, the biggest mistake people make at this point is thinking that they're done. Found it, right? Because what did I say? You have to find the point of intersection. Found it. Except this is our work, right? This is the problem. This is our work. I still have to write my answer. What is my answer for this problem? -3, -4. It's exactly right. That is my point of intersection. I'm not done till I have my answer written. Does everybody understand that? Okay? What's this called?
Point of intersection.
I agree. Point of intersection. Is there another thing that it's called?
The coordinate intersection. The root.
Uh-huh. It's called an ordered pair. It is called a coordinate. I agree with that, but ordered pair is what I need us to talk about. Ordered pair. Why is it called a pair? Two variables, x and a y, right? So is it important that we know the x and the y when we're looking for the point of intersection? Yes, we have to know both. Does everybody understand? So in Algebra 1, you learned 3 different ways to solve a system of equations. The first way you learned was graphing. Okay, we did that. Do you remember that now? Okay, do you feel comfortable graphing? If I gave you some problems to do, you could do that? Okay, so is it okay if we go on to the next way to solve a system of equations? Okay, that way is called substitution. Now we're not going to graph these, but we have room to write here, so we might as well use our room. Is that okay with you? Okay. -4x plus y equals 6, and -5x minus y equals 21. So to solve by graphing, how do we solve by graphing? That seems like a redundant question, isn't it? The way we solve by graphing is to graph it, right? To solve by substitution, I need to solve, S-O-L-V-E, for one variable. I need to choose one variable and solve for it. I have 4 choices at this point of which one to choose. I can choose this first x, I can choose the first y, I can choose the second x, and I can choose the second y. Does everybody understand the 4 choices? Okay? Doesn't matter which one you choose. Can you get the right answer no matter which one you choose? Yes. Is sometimes some of the variables better choices? Yes. Okay? I would choose -4 over -5 because it's like 4 is a smaller number than 5, right? Okay. I would choose this over this, right? I would choose to solve for this y over this x because this has a coefficient and this does not. But I would choose this y over this y because this y is positive, right? So I want to choose the smallest one that I can possibly choose, and if I have the option, make it positive. Make it be the positive one. Does that make sense? Okay, so are you guys okay if we choose to solve for this y right here? Okay, so if I'm choosing to solve for this y right here, how do I do that? How do I get this y by itself?
Substitute.
Am I paying attention to the second equation? No, not at all. How do I get the y by itself? What's with it? The 4x. So how do I get rid of the 4x? Add it to both sides. Very good. If I add 4x to both sides, 4x, I get y equals 6 plus 4x. You okay with that? So after I solve for one variable, this is my, I guess technically, for the record, this is step 2. Because you know what step 1 is? Don't panic. Step 1 is always don't panic. Especially with new stuff, sometimes you guys have a tendency to panic first. So step 1 will be don't panic. Step 2 is solve for a variable. Okay? Step 3 then is to substitute. Okay? I'm going to take what I just found for y, which is 6 plus 4x, and I'm going to substitute it into the other equation that I didn't choose. Okay? I chose the first equation to solve for y. I'm going to take what I found for y and substitute it into the other equation. Does that make sense? So I'm going to start writing the second equation, negative 5x minus, what did I decide y was? 6 plus 4x equals 21. Now how many variables are left? Just the one, just the x. Right now there's 2 of them, so I got to get them together, right? So right here, what do I need to do? Distribute. So I have negative 5x minus 6 minus 4x equals 21. So what is step 4? Solve. So I've got a negative 5x and a negative 4x. What's that?
Negative 9x.
Negative 9x. Is it okay if I do this right now? Can I do that right now?
Yes.
So I get negative 9x equals 27. Well, if negative 9x equals 27, how do I find x? Divide by negative 9. So x equals what? Negative 3. So now I'm done, right? No, why? Why do I have to find y? I'm still looking for the point of intersection. Just because I'm not graphing doesn't mean I'm still not trying to find the point of intersection. I have to have both variables, the x and the y, to have my point of intersection, right? So now that I have my x, then I have to find my other variable. How do I do that? Where do I plug it in to find y?
Plug x in the x.
Like up here?
Yes.
I mean, I could. But, yeah, couldn't I go here? Isn't y already solved for right here? Right? So can't I say y equals 6 plus 4 times negative 3? What is 4 times negative 3? So y equals 6 minus 12. So it's y. Negative 6. Now I'm done? Not yet, right? What am I looking for? The point of intersection. And yes, I have x and y, but what don't I have it written as? A point. I still have to write it as a point, don't I? So what's my answer? Negative 3, negative 6. I mean, couldn't I just write negative 6, negative 3? Does it really matter what order I put it in? Oh, yes, it does, right? Oh, yes, it does. I have to have x comma y. That's how we write our points, isn't it? Okay? Any questions about that? How are you feeling about substitution? Should we write a step 6 just so we have our steps written? Write as ordered pair. As I did the problem, or even before I started, but either before or as I did the problem, are you remembering this from Algebra 1? Yes? Feel confident about this? So is it okay if I show you the third way to solve the system of equations? Okay? The third way to solve a system of equations is with elimination. Okay? Elimination is the third way we're going to solve a system of equations. So let's do this problem. Negative 4x plus y equals 6. Negative 5x minus y equals 21. Now the thing about elimination is that by the name you can tell, hopefully, that I'm trying to eliminate a variable, right? Elimination, okay? If I'm going to solve a system by elimination, my final goal is to combine these two equations. Combine these two x's, combine these two y's, combine the constants, and when I do that combination is when one of the variables is eliminated. Okay? So the first thing I want you to notice is if I started combining them right now, what would happen to the y's? They would. They would eliminate, right? So what's true then about these two y's? They are the opposite, but same number, right? This is a 1, this is a 1, but this one's a positive 1, and this was a negative 1. So that's what I need. Now this first example, I did it on purpose because we already have what we need, and I wanted a way to quickly show you what's going on. In the next example, we won't have what we need, and we'll have to make what we need. Okay? But first I need you to recognize that we have what we need in opposite numbers, a positive 1, a negative 1, right? I couldn't add these two together right now and eliminate the x's because first of all, they're the same sign and they're completely different numbers, right? Okay? But because the y's will eliminate, I want to go ahead and add them together exactly as they are. So what is negative 4x and negative 5x? Negative 9x. What is y minus y? 0, right? So I don't have to pay attention to it anymore. I don't have to write 0y. I just leave it off because it's 0, right? And then 6 and 21. What's that? 27. So when I go to solve for x, I do so by dividing both sides by negative 9 and getting x equals negative 3. Thinking back to what we did with graphing and then again with substitution, am I finished?
No.
No, what do I need?
Your y.
I need my y. I need my other variable, right? I found the x first, so I need y. Where am I going to go back to solve for y? Which one? Last time there was already this one that we had found that was already y equals something, right? We don't have that this time, so where should I go? Either one, right? One of the first ones from the beginning. Does it matter? No. Which one would you choose and why?
The littler one.
The littler one, right? We want to deal with littler numbers if we have the option, right? So to you, the littler one is what?
Negative 4.
The first one, right? Okay. So if I take negative 3 and substitute it into the first one, I get negative 4 times x, which is negative 3, plus y equals 6. Well, what's negative 4 times negative 3? So 12 plus y equals 6. And then to solve for y, I just subtract 12 from both sides, yes? So y equals negative 6. Thinking back to what we did with graphing and thinking back with what we did with substitution, are we finished? Now, what do we have to do?
Point of intersection.
So what do I write?
Ordered pair.
Ordered pair, point of intersection is negative 3, negative 6. Now, before I even started, did that problem seem familiar? Yeah, we just did it. Why in the world would I do the same problem 2 times?
Simple.
Yeah, first of all, we did it 2 different ways, right? One substitution, one elimination. The second reason is I wanted to make a point. Sometimes substitution is pretty easy. This was pretty easy, wasn't it? But look how much shorter elimination was for this particular problem. Okay? Sometimes you're going to be given directions, like solve with substitution. solve with elimination. And sometimes you're just going to be told, solve. That means you get to choose. In a problem like this, substitution would be wise because you can look at it and see you already have same number opposite sign for y's, or sorry, you already have a y by itself, so that would be easy to solve for and substitute into the other equation, right? But elimination would also be wise because you already have same number opposite signs, and y's would eliminate very easily. Does that make sense? So sometimes it's not going to make any difference whether you choose substitution or elimination. They're both relatively short, right? What about this example, though? Negative 5x minus 8y equals 17. 2x minus 7y equals negative 17. Would this example right here be a good option for substitution?
No.
No.
I agree with you. I don't think it is either. Why is it not a good option for substitution if you're given a choice?
You still can't eliminate one.
Well, substitution, remember, what are we trying to find for substitution? A small, it's like this one's the smallest one, right? As far as the number-wise, not the negatives, because that's actually smallest of negatives, right? But this 2, and if I divide everything by 2 to solve for x, what's that's going to give me here? A fraction, and here? A fraction. So do you see why that may not be the best choice if we have to choose to solve with substitution? Okay? So elimination then would be our best bet, because it's already not a good idea for graphing, because what do I have to do for graphing? Think about it this. What do I have to have it for graphing? Y equals, right? Because I have to have the slope and I have to have the y-intercept. This one obviously is not y equals, but it's only one variable, so it's not a big deal. But for graphing, I have to get things y equals before I can start, right? So this is not a good choice for y equals, or for graphing. So elimination is kind of what we have left, right? So the first thing I need you to realize is in order to do elimination, I have to have my x's lined up, I have to have my y's lined up, I have to have my equal signs lined up, and I have to have my constants lined up. Some of the problems that you're going to do for work later are not lined up. And before you can even start, you have to get everything lined up first. Does that make sense? Okay? Now, I have two choices. I can try to eliminate the x's, or I can try to eliminate the y's. Do you have feelings one way or the other? Opinions?
I don't.
So think about this, okay? What do I need for things to eliminate? They need to be same number but opposite sign, right? Okay, so x's already have opposite signs, don't they? Okay? What number am I going to make these numbers into so that they are the same number using multiplication? 10, right? I can make 5 into 10 by multiplying by 2, and I can make 2 into 10 by multiplying by 5, right? What about the y's? Do you notice, first of all, that they're the same sign? So then one of my multiplying is going to have to be a negative number, right? What number would I make these into so that they're the same? 56. So I'd have to multiply the top by 7 and the bottom by 8. Yeah, that's the face I'm making too, right? I don't want to do that, right? Because here's the other thing. I said 7 and 8, but really one of them would have to be negative to make them opposite signs, wouldn't they? Okay? So would you choose to eliminate the x's first, or would you choose to eliminate the y's first? Probably x's, right? So if we're going to choose to eliminate the x's, that means the whole first equation has to be multiplied by 2, and the whole second equation has to be multiplied by 5. Okay? So if I multiply the whole first equation by 2, I get negative 10x minus 16y equals 34. Okay? I'm glad you could do that in your head. Dang it. I wish you guys would have already gotten calculators so you could be checking your math. Oh, you already have calculators? You want to get them out?
So, there.
Well, you'll know to bring it next time, right? I want your calculators in class with you every day. Okay? We may not use them every day, but you need to have them every day. All right, so what happens when I multiply the whole second equation by 5? What's 2x times 5? 10x. And what's 5 times negative 7y? 35y. Very good. And then 5 times negative 17? 85. Negative 85.
You don't even.
Are you okay with us combining them at this point? What's going to happen if I combine them at this point? The x's will be eliminated, won't they? Okay? So negative 10x and positive 10x is 0. Negative 16y and negative 35y is what?
Negative 51y.
Negative 51y. And 34 and negative 85? Negative 51. It's always nice when that happens, right? Because then when I go to divide both sides by negative 51 to solve for y, what do I get? Y equals 1. Am I done? Okay, not done. What do I need? Where am I going to go? You don't want to go here? Yeah, me neither. Could you go here? Yes, but the numbers are bigger, right? So if you're going to choose top or bottom, which one would you choose and why? First of all, does it matter? No. I would probably choose the bottom because I'm trying to solve for x now, right? And the 2 is smaller. Now, I'm not trying to get into an argument. If you want to be technical, negative 5 is smaller than 2. I'm not saying that. I'm saying the 5 and the 2. Those are the two numbers I'm comparing. Does that make sense? Okay. All right. So if I take the 1 and I plug it into the second equation, I get 2x minus 7 times 1 equals negative 17, right? So 2x minus 7 equals negative 17. So when I add 7 to both sides, I get 2x equals negative 10. And all that's left to do is to solve for x is divide both sides by 2, right? So x equals negative 5. So now am I done?
Oh,
You're so frustrated with me, right? You're like, no. What's the answer?
negative 5.
Negative 5, 1. Is it right?
Somebody check.
How could we check?
Calculator.
What do you mean with calculator? What would you do in the calculator to check?
Math.
Plug in your x and y.
Oh, plug in your x and y. Is there another way to check? I guess you could solve each one of these for y and then graph them and see if that's where they cross, right? But plug in is what you said first. So negative 5 times negative 5 is 25. 1 times 8 is 8. So 25 minus 8 is 17. Yes? So it works in the first one, so it must work, right? Oh, we have to check the second one too, don't we? Okay, so 2 times negative 5 is negative 10. 1 times 7 is 7, so negative 10 minus 7 equals negative 17. See, now you know without a shadow of a doubt that that's the right answer. Okay? Any questions? Guys, I didn't check this one. Why didn't I check this one the way that I just checked that, the one that we just did? We just did it. We knew it was right, right? But could we have checked it right here by plugging it in as well? Yes, for sure. Okay? Do you have any questions?